Here we'll look at an example from section 5.2. 5.2 continues our look at integration, and we just completed discussing our Riemann sums, which, as we know, are used to estimate the area between curve and the x-axis. And in section 5.1, we restricted our attention to functions which were always above the x-axis. Here we look at some other examples, and we begin to make this distinction between area and net area. When we talk about area in this course as opposed to net area, for area we're thinking of just what we normally talk about when we use the word area. Net area counts any region below the x-axis as contributing negative area. So we're thinking of area as having a sign to it. And so we determine how much area we have above the x-axis, how much we have below the x-axis, and the net area would be the difference. With area, again, we just count it all as positive. Net area is where we make the cancellation if there's some positive and some negative. So this particular example asks us to find the area and the net area of the region between the graph of y equals negative 3x and the x-axis for the interval from -2 to 2. And notice in the instructions it says use geometry, not Riemann sums. Very important. When you see that instruction to use geometry, you're expected to do exactly what that says, which is to use familiar geometric formulas for area of a triangle, area of a trapezoid, area of a rectangle. Okay, things that you either know or can easily look up to calculate exact areas. Okay, rather than estimate, which is what we do with Riemann sums. They're not asking for an estimation here. So we sketch this. Once we have a graph, then we can see that the region that's being described is made up of these two triangular pieces. One above the x-axis, one below the x-axis. And so we're asked to calculate the area. When we calculate area, we're just counting that all of that shaded territory there as positive. So we simply calculate the area of those two triangles, add them up, and we get 18. For net area, we count the triangle that's below the x-axis as contributing negative area. And that is exactly the same size as the other triangle. So the net area here is 0. Okay, so this is a good illustration of the fact that you can have a net area of 0. That does not mean that there's no shaded region involved. There is area here, but when we make our cancellation between positive and negative, we get a net area of 0. I hope you found that helpful, and I will see you in the next video.